Artificial lighting is easy. If you have a physically accurate model of the lamp fixture itself, and you have a physically realistic light source, you should get a pretty believable result. So in most cases, it's just a matter of trying to emulate the reality. So let's start with a simple example here. What I have here is a scene with 3 pendant lights. They are solid, not refractive, you can't see through them, so they would cast light only downwards. And I have some night sky set up outside the room. And basically it's the same setup I used in my night scene video. Okay, so let's try to light these 3 pendant lamps by adding some realistic light sources. And since the light bulbs can't be seen, we can get away by using some regular sphere lights. So make a sphere light, and depending on the type of the bulb, adjust the radius. So if it's a small bulb, it's something like 1.5. It's a regular bulb, it's something like 3 centimeters. And if it's a clear bulb, a regular sized clear bulb, you want to set the size to this spiral that emits light inside it, so about 0.5 centimeters. And this is important if you want to have a realistically sharp or soft shadows. So I'm gonna go for a solid white light bulb with a 3 centimeter radius. Set the multiplier to about, set the luminous power to about 1500 lumens, and this is about standard for a regular 100 watt incandescent light bulb. And set the mode from color to temperature. Since most light bulbs are provided with the color measured in the kelvins, or the temperature, and it usually ranges from 2,500 kelvins to about 6,000 or 8,000, so basically from orange to blue. And for some regular incandescent lights, I would say something like 3,000 or 3,500 should be alright. Okay, so set up that color. Make sure the light is visible and affects speculars and reflections. And now just position the light as you would position the real light bulb in the real pendant lamp. So maybe somewhere over here. And make some instances for the other lamps. And this way you can easily adjust one of them, and the rest will be changed automatically. Okay, so now I'm gonna go ahead and render the scene. And here's the result. As you can see, it looks pretty good. So the thing I mentioned about the light bulb size, for example, if you had a clear bulb, you would set it to about half a centimeter in radius, and the difference would be noticeable here in these shadows. I'm just going to re-render this area, and as you can see, the shadows are quite a bit sharper if we use a smaller bulb size. But anyway, that's up to you. It's an artistic choice you have. If you want sharper, set the radius smaller. If you want softer, set it larger. Okay, so this is the first scenario I wanted to show you. Next, I'm going to show you these same lamps, but with a different material. So I'm just going to instance those bulbs to my next scene. And in this case, I have transparent white glass material set up for the pendants. And here's the material itself. Let's wait for it to load. It's a bit slow. Okay, so it's a basic white material, sharp reflections, Fresnel on, and blurry refractions. And for these refractive glass lampshades, you need to make sure you have set up the effect shadows option to be turned on, so the shadows are cast in a realistic way. Otherwise the scene is going to look pretty much the same as the one with the solid pendants, and it will be too dark and not really that believable. So let's render this one and see how it looks. Alright, so here's how it looks, and notice that it has a bit more noise and it renders quite a bit longer, and that's the price you pay for maximum realism. So as you can see, if you adjust the exposure of your render, the light fall off looks pretty good, and in the reflections you can see the bright spot in the middle. So if you're using some HDRI mapping or tone mapping afterwards in post-processing, you can get back these details and have a realistic look for those lamps. Okay, so in this case it's best to not use any fakes, since these are pendant lights with the bottoms open. So this area right here should be brighter than the rest, and that's exactly what happened in this render. But there are some cases when you can use some fake techniques to speed up the render quite a bit, and I'm going to show you one example right now. Okay, so here's the scene, and the lamp here is a huge round sphere. So basically you would have a light source inside, and the light would get slightly dimmed by the sphere and diffused throughout the whole room. So if you would render it using the same technique I just did for those pendant lamps, it could be quite long and quite noisy, so you can use a simple fake to simulate this effect. So in this case I recommend creating a new material. So here's the material for the lamp, and basically it's just some simple glossy white V-Ray material set up as V-Ray two-sided to give it some translucency. And it's going to render quite fast. And in this scene I'm going to use two lights. So one bulb will be used to light the lamp itself. So let's say 3 centimeters, 1,500 lumens, seems about right, position in center. Okay. And for this light you're going to go to exclude and select include only the sphere light, or this large round object right here. And what's going to happen is that once you render, you're going to see that this light only affects or illuminates this large round lamp itself, with proper light fall off in the reflections, where the light is weaker, or after adjusting the exposure. So all that is nice and good, but how do we light the room? So since the light gets diffused by this whole large lamp, we can just use a simple V-Ray sphere light, increase the size to approximately match that of the lamp, and just set it to exclude the same sphere light. Exclude, okay. And for this particular light we want to disable visibility, so make sure it's invisible, and effect specular and effect reflection should also be off. Now when you render, you should get a pretty nice result. And this usually renders faster than if you would light it using this single light source inside and refractive glass material for the lamp. As you can see, this area renders very quickly, since the V-Ray two-sided material is pretty fast. And here's the render. You can see that it rendered very fast, and the light distribution looks okay in these dimmed reflections, and the light also looks quite good. You have this detail to recover if you're using some tone mapping. So this is a good way to speed up your renders and still get a realistic result. So this works the best if you have completely enclosed bulb. So there are no spots that should be brighter and no spots where you have this direct light. Everything is illuminated by this diffuse large enclosure. Okay, so the V-Ray two-sided material can be used in some other scenarios as well to quickly render the lampshades, especially if the lampshade is made from cloth or paper. So like in this example, we have this paper lamp, which can be also illuminated with a single light inside, and it has a V-Ray two-sided material to make that translucency effect. And one thing you should keep in mind when using V-Ray two-sided material is that the object should only have one-sided geometry. It should not have a thickness, like you do not want to use shell or anything like that on this object. In that case, the material will not work correctly. But you absolutely must use shell if the material is glass or plastic or anything other than V-Ray two-sided. So keep that in mind as you're modeling the object. Keep in mind the final material. So let's make a light bulb. Let's say 3 centimeters. And just move it somewhere over here. Okay, and let's render and see how it looks. In this case, we do not want to use any exclusions or overrides, since the goal is to have these shadows look pretty realistic, with the star pattern on the bottom around the dining table. Alright, and as you can see, we have a realistic shadow pattern on the bottom here, and we have a lot of detail to recover in the paper lamp itself. Okay, so in my opinion, V-Ray two-sided is one of the best options if you need quick renders and if you have a lampshade made from cloth or paper. So next up, I'm going to show you a lamp that presents some different challenges. Okay, and in this case we have this lamp where the light bulb is directly visible, and I actually modeled it roughly. Okay, and you also have the lampshade, or the lamp that's going to cast some sharp shadows. In the real world, if you would use a clear bulb right here, the resulting shadow should be pretty sharp, since a real incandescent bulb casts all the shadows from a pretty small area, or the tiny wire that's illuminated. So in this case, we're going to use some fake methods to create a faster result. So let's start with this light bulb. Let's pick the material, and it's your basic glass with the effect shadows on. And it's just a regular glass material. And what I want to do is I want to create a small V-Ray light inside it. Something like 0.5 centimeter in radius. Alright. And this light bulb is gonna cast all the shadows in our scene and illuminate our scene. So basically, let's keep it visible so we can add some glare or blur or bloom in post-production to blow out this area around the bulb a little bit. Enable speculars, enable reflections. And what I want to do is take this light bulb right click, go to Object Properties, and take off these two checkboxes here. You do not want the light bulb to cast any shadows, and you do not want it to receive any shadows. And this way it will be illuminated, but it will not mess with our shadows, and it will make the render quite a bit faster and easier to adjust. Right, and also take the light bulb, right click, V-Ray Properties, and turn off this option here, Generate GI. So if it doesn't generate GI, if it doesn't cast any shadows, it's gonna render quickly, and it's not gonna mess with the rest of the scene. Let's make sure that light bulb is positioned in the center. Come on. Right, and move it right here. And let's see what happens. Alright, and here's how it looks. We have the shadow pattern exactly like we would expect from a single light bulb. And if you look closer, you can see if we adjust the exposure, there's a hint of the bulb itself, but the bright spot is pretty small and somewhere right here. So if you add some glare effects or something like that, it's gonna look pretty realistic. Alright, let's go to our next example. Sometimes there are lights that have tons of small LED lamps, like maybe this lamp here. Okay, so basically you have this weird hedgehog shape with small LED lamps at the ends of those sticks. And it would not be reasonable to light it by creating these hundreds of light sources and expecting the scene to render quickly. So what I do instead is I create a material with some self-illumination, bump up the multiplier a bit, turn off the GI, and basically you have this bright material that's not really illuminating anything else except the object itself. And since there's tons of these light sources and they're spaced over a large area, we can actually use a similar technique like we did before. We can fake it by creating a large circular V-Ray light that roughly matches the size of our lamp. Okay, so create a light like this and exclude the lamp itself from both illumination and from shadow casting. So hedgehog lamp, exclude, okay. And maybe let's bump up the luminous power a little bit. 1800. Make it nice and bright. Okay, so set the light to invisible, turn off speculars and reflections, and let's render and see how it looks. And in this case, if you have a single large light that lights the scene, it's much easier on the V-Ray sampler, on the V-Ray GI sampler, and it's going to be a faster render and the results are going to be cleaner. If you would try to use hundreds of little lights, it could take a while and look quite splotchy. Okay, and as you can see, the results are pretty good and pretty clean. So let's move on to our next example. Okay, now I want to show you how to light the hidden lights that are sometimes used in scenes like these. So basically you have a seam along the side of the ceiling and that's supposed to be lit with some sort of lights. And many people that have not seen these lights in real life or do not know how they are constructed in real life usually use a technique like this, where they create a light, point it directly downwards. Okay, so plain light, point it downwards and expect it to look good. That's really not how it works. You do not put the lights in this direction, since if you can see them in render, it looks weird, they are too bright or they are too aliased, or the light distribution looks weird. In real world, the lights are made so they are facing in a way that it's not possible to see the lights from the room itself. So you have this little profile right here for the ceiling, and this little niche here is meant for the light to go in. And you can either point the light upwards, or you can point it towards the wall. So basically, let's create a VRay plane light. I'm pointing towards the walls. And I'm gonna reduce my width and position it somewhere over here. And you can also leave it as an invisible light, but turn on the speculars and reflections. Doesn't really matter, you can also keep it as visible light. Okay, so let's set the color to something cooler, maybe 8000 kelvins, and I'm going to change my multiplier from luminous power to luminance. And this way the intensity of light will be exactly the same, and it will not matter how large the light is. The amount of light emitted from 1 square meter will be the same. So let's set it to, I don't know, maybe 1400 for now, and let's see how that looks. Let's make an instance on the other side. And 2 more lights. For the shorter length. Okay, rotate, adjust the size. Make sure the brightness stays correct. 1400. And let's see how that looks when we render. Right, and here's the result. And to make this type of scene a bit more interesting, this hidden lighting is usually combined with some regular lights. For example, let's turn on this pendant light here. And it's also nice to combine cool lighting with some warm lights. That usually makes for a nice effect. So I'm gonna take that VRay light and instance it right here. Actually, let's make a copy. Okay, and maybe let's bump up the luminous power. Right, let's re-render and see how it looks with some additional warm lighting. So as you can see, some warm light can give the scene a much more interesting look. Okay, so this is simple to do if you have rectangular ceiling with rectangular areas for these hidden lights. I'm also going to show you one more example with hidden lights, and it's going to be this one with this circular area right here. And this one is a bit more tricky, since you can't use rectangular VRay lights. Okay, so I'm going to zoom in and you can see that I have the same type of ledge, but this time facing inwards. And what I want to do is I want to position some lights right here and point them upwards towards the ceiling. And the easiest way to do this is simulate the way it would be done in the real world. Basically, you have a bunch of LED lights or something like that arranged in a pattern. Since I have this squished circle pattern, I can just trace it with a shape. So for example, I'm gonna create a circle. Okay, collapse to editable spline and squish it like this, so it approximately matches the shape of this ledge. Okay, let's move it somewhere up here. And basically I want to take a simple V-Ray light, set to plane, okay, I'm gonna set my size to 2 by 2 centimeters, rotate it upwards, look at the settings. Okay, everything seems fine, except for the luminous power. We want it to be pretty low, so maybe something like 100 lumens or so, since there's going to be so many of these lights. It's best to keep it low. Okay, so now take that light, go to Tools, Align, Spacing Tool, and pick your path. And once you increase the number of instances, okay, sorry, let's try again. So select your light, align, spacing tool, and pick your path. Okay, that's better. Okay, right now the rectangular lights are sort of just spaced without rotating them, but you can turn on context, follow, and they should be rotated as well. And let's space them approximately like this. I think 120 should be enough. Set them to instances and click apply. Right. Well, let's take those lights. Looks like they got turned around, upside down, so let's flip them on the z-axis, actually y-axis, and move them in the correct position. So that should be somewhere over here. Okay. Also gonna bring in the spherical light for my pendant. From our previous example. Make a copy. Okay, so now you have this bunch of lights, and you can control all of them at once by adjusting one of them, since they are all instanced. I'm just gonna quickly render this little area right here. And right now it kind of looks much too bright. So let's bring down the luminosity to maybe, I don't know, 30 lumens per light. Since there are so many of them, you can actually calculate the total lumen output. Let's say 120 by 30 lumens, that's 3600 lumens of light for this whole area. I think that's not too bad. We might need to adjust our exposure. So I'm gonna select my camera and okay, select the camera and turn down exposure a bit. maybe 1/2 of a second for the shutter speed. And let's render the whole thing and see how it looks. And here's the result. So not too bad. Next up we have recessed lighting. So basically what you have here is a bunch of recessed lights cut into the ceiling. So basically some small powerful light source with a reflector that casts an interesting pattern of light directly downwards, or maybe not directly. Sometimes they can be adjusted so you can cast the light in a slightly different direction as well. So the easiest way to light this is by using regular V-Ray plane lights. For example, let's set the luminosity to maybe 300 and make a smallish light, a bit larger than the bulb itself, so maybe 2 by 2. And position is somewhere below the light source. Alright, so next up you want to make sure this light is invisible and that it doesn't affect speculars and reflections. We just want it to cast some light. I'm also gonna set the color to something a bit more yellow, maybe 4000 kelvins. Okay, and let's just instance them for the rest of the recessed light. If you make them as instances, you can just adjust one of them and the whole lot changes. It's a bit faster. Okay, perfect. And for these light bulbs themselves, I'm just using a regular V-Ray material with some self-illumination. Bump up the multiplier so the spot is really bright in the render, and you're good to go. So let's render and see how it looks. And right now you can see from the light cache that the light sources do not really look like spotlights or recessed lights. I think the light should be a bit more downwards. Right now it's kind of diffused in all directions simultaneously. And this is where you can use a parameter on your V-Ray lights, and it's called directional. You can actually point the light rays specifically in a single direction. So if it's set to 0, they go in all directions. If you set it to something like 0.5, you can see that the light is quite a bit more focused. Okay, that seems to be a bit more realistic. Still, let's say I want to make them even more focused. I can bump it up to something 0.75. I usually wouldn't go higher than that. Alright, and let's adjust the exposure for the camera to match with the amount of light we have in our scene. So something like 1/4 of a second should work okay. Alright, so as you can see, sometimes when you have On these recessed lights you can get by with just simple V-Ray plane lights with directional parameter turned up, and you do not need any fancy photometric lights or anything like that. But sometimes there are cases where you want slightly more interesting patterns of light cast on the walls, and that's the case where you actually need to use those photometric files. And basically I suggest you download the IES Viewer software from photometricviewer.com. Here it is. And you can get the files, the IES files for free. Just write down something like download IES lights in Google, and for example here in the second link you can download hundreds of different IES lights for different lamps and different light sources. So for example, I've opened my IES Viewer, and here in this folder you have some different makers, different types of lights. For example, here's a light. You can press the render button to see a preview. It actually looks pretty similar to a regular V-Ray plane light with slightly increased directional parameter. But there are many cases where that is not the case. So for example, you have some different patterns. Okay, let's look at some incandescent lights. Okay, for example, this one. You can see that the rays cast from the lamp are not uniform in brightness, and they have these interesting patterns going on. And you can easily recreate that in V-Ray by using V-Ray IES lights. So in the next scene I'm going to show you exactly how to do that. So here the scene is the exact same scene, but we're going to use the IES lights for lighting it. So create a V-Ray IES light. Maybe bring the target downwards. And I'm just going to create a few instances. Okay, and just position them over the light bulbs, just like you did before with the regular plane lights. Right. So now let's select one of those lights. And let's assign an IES profile to it. So just click this button here and choose one of the lights. Okay. Let's try this one. All right. And I'm going to use the light shape for shadows only. There's really not much of a difference between shadows only and illumination and shadows, but maybe for shadows only is a bit quicker. And you can override the shape and set it to, for example, a sphere. You can set the diameter to control the sharpness of the shadows this light casts. So let's say it's about 1 centimeter large. I'll set the temperature to maybe 3,500 kelvins and check the render. Okay, seems a bit too bright. I'm gonna adjust my camera exposure. And try again. So as you can see, you can get some interesting light patterns from these photometric files. And the only cases where I would actually use them is if I have recessed lights that need this sort of effect, or maybe some wall lights that have a similar effect, only on both sides, on top and on the bottom, and for some spotlights as well. I'm going to show you some example with spotlights now. Okay, so I have a scene here. I changed the wall color to black to make the effect a bit more visible and more interesting. And I have these 3 spotlights on top of the dining table. And basically, my preferred way to light them would be using photometric lights. So create some VRAIS lights. Right. I'm just gonna freeze everything else so I can position them a bit more easily, and move them right here. So the first one goes pretty much right down. Make an instance. And for this one, let's move the target somewhere over here. And another instance. And let's point it over here. Let's check to see if our lights are not obstructed by anything. That could cause some weird issues. Okay. And maybe let's move them downwards a little bit. So sort of like that. And this time I'm going to use a different IES profile. I found one with a more interesting shape. Well, not more interesting, but more concentrated shape. If you zoom in closer, you can actually see the shape. So it's thin and longish. And change the color to maybe, I don't know, 5000 Kelvins. And this is a cool effect to use for these dark interiors where you have dark walls, dark ceilings, and maybe some sort of piece of furniture or any other accent piece brightly illuminated with some spotlights. I think it looks pretty cool. Okay, I'm just gonna increase my my shadow softness by creating a spherical area shadow with small diameter. Like that. And adjust the exposure for the camera. Like this. And let's render and see how it looks. And there you have it, some pretty cool looking spotlights using the IES files. There's also another method you can use for the spotlight effect, and that is the standard spotlights from 3ds Max Lights. And the results are, well, they are not as realistic as with the IES files, but it's sometimes okay to use them as well. I'm going to show you how that looks. So let's create some standard lights, target spot, and just roughly position them in the same way as we did for the photometrics. Okay, so 1, 2, and 3. All right. Let's see how that looks, and you can see they are much too bright and they are much too sharp. And there are a couple of options you can use to fix those problems. So first of all, check the intensity and try it at 0.1 and set the color. In this case, you can't use a Kelvin's value, you can only set the color manually. Well, it's a bit more flexible, but it's not exactly easy to match with the light bulbs in real world. So let's say something yellowish like this, maybe a little bit less. Okay. And check the spotlight parameters. You want to reduce the hotspot and maybe increase the fall off. And this should give us a much softer look for the spotlights. Okay, maybe it's a bit too large. So let's try it at 50. And I think I'm gonna settle on something like 60 or so. Okay, that's good. I'm also gonna adjust my camera to be the same as for the IES spotlight scene. And try again. Alright, not bad. But the shadows are perfectly sharp right now, since all the light is cast from a single point. So we want to go down to V-Ray shadow parameters, enable area shadows, and set the sphere size something like 1 centimeter or so. And that should give us a more realistic result. Okay. And there's one more thing you need to do for these spotlights to function like real lights, like realistic lights. You want to enable the K option. Set the type to inverse square. Okay, and let's start it at maybe 1.5 meters or so. And this means that after this point, the light becomes gradually weaker as it goes further from the source. Right, and let's bump up the intensity a little bit. And theoretically, this should give us a more realistic result. Okay, and let's wait for the render. And as you can see, the result is not too bad. So in those cases where you want specific controls over the size of the spotlight and decay and things like that, you might use the standard V-Ray, the standard 3D Max spotlights instead of photometrics. So, but for maximum realism, stick to the photometrics. Right, and there's one more example I want to show you regarding the artificial lighting. And it's somewhat extreme or maybe unusual, and that's when you have some sort of a lamp. It's made from crystal or glass and is supposed to cast some crazy looking caustics in the scene. So for example, here's a small light bulb that shows sound effect, or some larger lamps. You can see these crazy light patterns on the ceiling that are generated by caustics. And if you would use standard V-Ray lights for generating these caustics, this would be very slow and very inefficient. So what you want to do is, I'm just going to show you. So first of all, make sure your crystal material doesn't have the option affect shadows turned on. Make sure it's off, otherwise the caustics won't work correctly. And next you want to create a smallish V-Ray light for illuminating the scene. Okay, so let's create a sphere light, 0.5 centimeters in size, and position it somewhere over here. Okay, let's make sure it's set to correct intensity. Say 1.5 thousand lumens. Make it visible to reflections as well, and position in the center. Okay, so next what I want to do is I want to make sure that this light does not affect caustics. Go to V-Ray properties and turn off the generate caustics option. And same for these other V-Ray lights, you want to make sure that option is turned off. Okay, and I think I've already done that. Yep, so these lights do not have caustics as well. So if you render right now, you get only this shadow pattern on the bottom, but you do not get any nice caustics in the scene. To add them, we need to create a regular V-Ray, a regular 3D Max Omni light. So create this standard Omni, somewhere over here. Make sure the light bulb does not receive or cast any shadows, just like before, and also that it does not generate GI. And position the Omni light somewhere in the center of the bulb. Okay, now go to exclude and select everything, all the objects in the scene, and exclude them from this Omni light. And this way, this light will not cast any light in the scene, but it will only generate caustics for V-Ray. So to get a decent strength for those caustics, you need to increase the multiplier quite a bit. So maybe 1200 or something like that. Right. So by default, the caustics are not rendered. You have to turn them on in the V-Ray indirect illumination settings. So go down here and turn on the caustics and render. And it actually seems like I need to move this Omni light outside of the bulb and try again. Right now it seems to be working. Alright, and as you can see, you can get some very crazy caustics in a pretty short time. Just 3.5 minutes to render the scene. If you use some fake techniques like Omni light instead of V-Ray lights to generate these caustics. Okay, and as long as we're doing some fakes, I also not too happy with the reflections on my crystal lamp. It seems very flat and boring, and I want to add some fake reflections to it. So for now I'm going to turn off the caustics, and I'm going to add some invisible V-Ray lights to fake the reflections. So let's create a V-Ray light, a bit larger than the chandelier or the lamp itself. Move it upwards, let's say somewhere over here. And set the brightness to maybe 500 lumens. Okay, like that. And we're gonna use a texture for this light. For texture, I'm just gonna use some basic V-Ray softbox. First of all, with some frame, so it becomes softer as it goes out from the center, and maybe some hotspot as well. Let's turn on hotspot. And that looks good. And also want to make sure these black parts are transparent, so I'm going to run V-Ray softbox through an output map and multiply my alpha, or create my alpha from RGB intensity, so the black areas will be transparent and invisible. So go to use texture, instance that's texture right here, and let's render this small region with the chandelier. Okay, first of all, make sure the light is invisible and it affects reflections only. And now we can render. and you can see the lamp looks quite a bit more interesting. Here's this bright reflection, and all these cuts are reflective as well. Might be fake, but sometimes you have to fake these little things to get exactly what you want in reasonable amount of time. So that's pretty nice. Maybe change the hotspot color. Okay, just change the whole thing. And let's try again. That makes it a little bit more yellow, a bit more realistic. You can use these fake reflective planes in different areas. You can place them on sides of the lamp, on the bottom, on the top, wherever you need to bring in those little extra reflections. But there's a little problem right here. If you render the window, you're gonna see the light in the reflection, and that's not what we want. We want the light to only be visible on our lamp. And to do that, just take that lamp, take that light. Okay, let's bring down the intensity a little bit and click the exclude button, choose include, and only include the lamp you want the reflections to be visible on. So set it to include only the crystal lamp. And once you render, you're gonna see that there are reflections on the lamp, but no reflections in the window of that light itself. So that's pretty cool. And it's a quick way to make your lights more interesting. Right, so let's turn the caustics back on and see how the scene looks after all these adjustments. Maybe even make one more light on the bottom to cast a reflection on this bottom rim here. So there you have it, some fake caustics with fake reflections, if you really need them. If you don't need the caustics, feel free to just treat this as a regular pendant light with regular glass. Right. So one more tip I want to show you is what to do in daylight situations where you want the light sources to still be visible. So I'm going to set up a V-Ray skylight in my environment slot. I'll change those lights to sky portals. Okay, and change the exposure for daylight. Something like 1/10 of a second with ISO 100. And as you can see, our paper lamp is quite dark. And this is a common problem with daylight scenes where you want to turn on the artificial lighting and still make it visible or make it interesting. And this is a problem in real life as well. So interior photographers, professional interior photographers usually carry with them some halogen light bulbs with high lumen output. For example, something like 3,000 to 5,000 lumens would not be uncommon. I wouldn't go higher than that, but you can easily try something like 4,000 lumens, and it should still be realistic compared to professional interior photography. Okay, maybe even 5. I think this looks alright for a daylight scene with white walls, light floor and light or white ceiling. If you want to increase the brightness of this lamp further, I suggest you do it in post instead of cranking up the light multiplier. I really wouldn't go higher than 5000. Right, so I think this about covers the basics for artificial lighting